Okay, let's run through and do this practice test really quickly. It says find the domain and range of each one of these. So we need to find the domain and range. Notice that this one right here might be helpful to do a quick draw. We don't have any square roots. We don't have any division, so there are no domain issues here. This would be a parabola that opens down and has been moved up 4. So the domain is going to be anything you want, negative infinity to infinity. The range is going to go from way down here at negative infinity all the way up to right there. So that's going to be from negative infinity all the way to positive 4. And it's going to include the positive 4. So we're going to put a square bracket around that. Top half of a sideways parabola, that plus 2 inside with the x actually moves it back 2. So it looks something like that. So the domain on this one is going to be from negative 2 all the way to infinity in the x direction. I'm going to have a square bracket around here because it does actually have a point there. And then the range is going to be, well, this only gets answers, doesn't have any negative answers. It only goes from 0 up to positive infinity. And then if we've got a graph and we're finding domain and range, that's really pretty easy. So the domain is going to be all the x-axis because you can squish this onto the x-axis, cover everything. So the domain is going to be from negative infinity to infinity. And then the range is going to be only from here up. So it starts at negative 2, and then it goes all the way to positive infinity. So from negative 2, we're going to include that, and then we're going to go all the way to positive infinity. This is a linear function right here, and linear functions are kind of nice. You can plug anything you want, and you're going to get any number out if we've got something like this that's tilted. So this is going to be from negative infinity to infinity, negative infinity to infinity on both of those. And then what we want to do right here is we want to find the intercepts. So remember, if you want to find the intercepts, make a little xy table. We're going to plug in a 0 for x. That's going to find the y-intercept. And then we're going to set y equal to 0. That's going to find the x-intercept. So let's do the easy one first. Let's plug in a 0. So if I plug in a 0 right here, 2 times 0 is going to be 0 plus 2. So we're going to end up with y equals 6. So this is going to be 6 right here for the y-intercept. And then let's see, if I set this equal to 0, when we say y is equal to 0, we're going to put in a 0 for that entire f of x. And then we're just going to solve this. So I solve that by subtracting 6. That's going to be equal to 2x. We're going to divide. So we're going to get x equals negative 3. So that would be negative 3. So we've got an x-intercept of negative 3 comma 0. And we've got a y-intercept of 0 comma 6. So there's our answer on that one. And then we've got the same type of thing on this one. If I plug in a 0, that's going to turn that into a 0, and that's going to be minus 5. So that means the y-intercept is going to be 0 comma 5 because we plugged in a 0 and got out a 5. If I set it equal to 0, so I'm going to set that equal to 0, this is going to be negative 3x minus 5. I'm going to add 5 to both sides. So I get this. I'm going to end up with a fraction because I've got a divide right there. So this means the x-intercept is going to be negative 5/3 comma 0. So there's the y-intercept and the x-intercept. I've kind of written them in a backward order there. Okay, if we take a look at this one right here, we probably have to graph this. So I'm going to pull up the calculator. I've got a couple of these in here. I'm going to go ahead and hit graph. You'll notice that this one does not cross the x-axis. So x-intercept, we're just going to write none. And then for y-intercept, we're going to have the calculator figure that out. But it really shouldn't be too hard. So if I hit trace on this one, it says 0 comma 5. I could also, if I was in trace mode, hit this. But take a look right here. If I plug in a 0, those are both going to turn into zeros, and then that's going to leave a 5. So that means the y-intercept would be 0 comma 5. And there we go for that. Now, if we take a look at the bottom of the page here, we've got number 8. We're going to use a graphing calculator to help us sketch this and then analyze the function according to those things. So I'm going to go back to y equals. I'm going to turn that function off, and I'm going to turn the other one on, and then I'm going to hit graph. So it looks like this. Now, if I hit trace, I get an interesting point. So I'm going to go ahead and graph this one right here. I'm going to zoom in just a little bit so I've got a little more room. So this is going to be 0 comma 2. So it's right there, 0 comma 2. And then if I try and find the maximum, so I'm going to hit, let's see, so I hit second calculate. I hit number 4. Now I need a left bound. I'm going to type in like negative 2 because that ought to be plenty. And I'm going to type in a 1. That ought to be plenty. So it's somewhere in between there. That looks pretty good. You can guess if you want, but this is what the calculator says. Now, sometimes we get really lucky and it gives us an exact value. Other times we've got something that's just kind of close. The calculator goes through a numeric algorithm and just gets as close as it can. So that means -1/2 and 2.25. So about right there. So I'm going to draw a line up here, and I'm going to write vertex is at, this would be -0.5, and then 2.25. We could change that into a fraction if we wanted to. And let's see where it is at -1. It's at 2. So notice the symmetry right here, -1, 2. We'll type in -2. That's at 0. So -2, 0. And I'll do one more on this side, -3, -4. Now I'm labeling way more points than I need to. Let's go on the other side. Let's type in a 1. So that would be 0. Again, we're noticing the symmetry here. So 1, 0. And I bet this next one, I bet if we type in a 2, I bet it's going to be symmetric with that. It is -4. Okay. So 2, -4. And the graph would look something like this. Okay. Doesn't have to be perfect. We've got it labeled and everything. Domain, clearly -infinity to infinity because it's a quadratic, no domain issues or anything like that. The range, it's going to start way down here. It's going to stop when we get here. So this is going to be from -infinity all the way up to and including that maximum value, 2.25. So I'm going to do a square bracket around that. The x-intercepts, we found those. So -2, 0 and 1, 0. And the y-intercept was 0, 2. And the max, it does have a max, and the maximum is at -0.5, 2.25. So that's the point. And again, try not to get confused with the things that are points versus the things that are intervals. Okay, we're going to flip the page over and we're going to take a look at the same type of problem, but this time they're going to ask us different questions about it. So I'm going to go back here to the y equals menu. I've got this next one all set. All I have to do is just turn it on. And you'll notice how similar the two of these are. This one just has, instead of +2, it's +6. So we should expect the exact same type of shape, maybe just moved up just a little bit. So I'm going to go ahead and hit graph, same type of shape. I'm going to have it find the maximum because we do need to sketch this. So I'm going to do the calculate. So that's going to be number 4. Whoops, I need to back up here. I need to find the left bound. I'm going to go here at -2. And I'll go +2 for the right bound. And then you can take a guess if you want, but it's going to find that. Again, this is one where it numerically got pretty close, so that's going to be -0.5 and 6.25. So we're going to be about right there. So -0.5, 6.25. There's the maximum. And then let's just go over here. Let's hit a 0, 6. Okay, so 0, 6. And then let's check the other side. Let's check -1. Lo and behold, that's in the right place. So -1, 6. And then we'll do just a couple of others. Let's see, -2, 4. All right, -2, 4. And then let's see where we get at -3. Nice. We do need this point because we need to know where the x-intercepts are because of some of the questions that are coming up. And I bet we'd have a symmetric point over here, but let's check and see. Let's type in a 1. We get a 4, and that means if we type in a 2, we're going to get a 0, okay? So this is going to be 2, 0. Now, I could label more points. I could label this all more completely, make everything look nice, but here's what I'm after. Where is this increasing? Remember, when we say where, we're talking about where on the x-axis. So this is increasing on that part of the x-axis, and where is it decreasing? It's decreasing on this part of the x-axis. So it's increasing from way over here on the left, -infinity, all the way till it reaches that maximum value, which happens at 0.5, so to -0.5, and then it decreases the rest of the time. So that's going to be -0.5 all the way to infinity. Then we change tact a little bit. This says, where is it positive? Well, it's positive in between the two of these. Where is it above the x-axis is another way to answer that. And then where is it negative? Well, it's negative over here and it's negative over here. So it's positive between these two x-intercepts. So that's going to be from -3 all the way to 2, round brackets, not because this is a point, but because that's an open interval. And then where is it negative? It's negative from -infinity all the way until we get to -3. We'll put a little union in here, and then it starts up again and goes from 2 to infinity. Now, where is it constant? Where is it perfectly flat? Okay, we can put NA, we can put never, we could put doesn't happen, whatever we want to put there. Now, I think we're done with the calculator. Let's just double check and see where we are. Okay, this one says algebraically, we want to show what type of symmetry it has. So let's take a look at symmetry. So when we find symmetry, we're going to do this. we're going to plug in a negative x, and we're going to simplify, and we're going to see if we get exactly the same thing or the exact opposite. So remember, if it's even, we're going to get the exact same. If it's odd, we're going to get the exact opposite. Okay? So when I plug this in here and I square this, I get two negatives, that makes it positive, two x's, that's going to be x squared. Nothing happens with the negative 2, so we take a look at that. Is it the exact same? It is. So because it's the exact same, it's going to be even, which means it's symmetric with the y-axis. So symmetric with the y-axis. Y-axis. Okay, symmetric with the y-axis. Let's take a look at this next one. We're going to do f of negative x. We've got a negative 2, then we're plugging in a negative x and we're cubing it. So there are three x's, three negatives, and another negative out front. That's going to make this a positive 2, and we've got those three x's right there. So again, compare it with the original one. Is it the exact same? Nope. Is it the exact opposite? Well, yeah, it's the exact opposite because the original one was negative 2x cubed. Now we've got positive 2x cubed. So this is going to be the opposite. So this is going to be odd, which means it's going to be symmetric with the origin. It has rotational symmetry about the origin. Okay, take a look at the next one. When we plug in a negative x, here's what happens. I'm going to have absolute value. That's a negative x minus the 2 in absolute value, and then I'm going to have the minus 3. Now, take a look at that and think about how you'd simplify it. So one of the pains with working with absolute value is we've got to find a way to simplify this because you can't just say, oh, I just turn those into positive. You have to do the math inside and then take the absolute value. So what I'm going to do is I'm going to say, look, that's a negative x minus 2. Nothing happens on the outside. But then I can control a couple of things about this. If I take out a negative 1, I'm left with an x plus 2. So I'm basically factoring out a negative. And then I can control this part right here. I'm going to take the absolute value of negative 1 and the absolute value of x plus 2. And then I've got the minus 3 right here. So I'm going to write this a little more clearly. Absolute value of negative 1, I know that's positive. We can control that. This is a variable expression. So we don't know what it is. We've got to have a number to plug it in before we figure out whether it's positive or negative or what the actual value is. Now we're going to come back here and we're going to compare these. They're clearly not exactly the same because this has a plus and that one has a minus. And they're not the opposite because if it were opposite, we'd multiply that by a negative. This would be negative x minus 2, and that would be a plus 3. So this one is a big fat neither. Okay? All right, now let's talk end behavior and then we'll finish this up. So it says determine the end behavior of each function. Let's stop and think about this. This has been moved left 4, top half. That means on the left end, so the limit as x goes to negative infinity of f of x, there is no left end behavior. So I'm just going to write NA on that one. And then the limit of as x goes to positive infinity. So this is the right end behavior. It just continues going up and up and up as we go to the right. So that's going to be positive infinity. Okay, so those are those two behaviors. Linear function like this crosses at 5, slope down from left to right. Pretend that crosses at 5. So left end, again, limit as x approaches negative infinity. Right end, limit as x approaches positive infinity. And we'll just write f of x as a bit of a shortcut right here. So as we're going to the left, the function actually gets bigger. So that's going to be positive infinity. As we're going to the right, the function actually gets smaller. So that's going to be negative infinity. So there's the behavior of that one. And then think about this right here. If you want to graph this, you're certainly welcome to. But this right here is what makes it a quadratic. That's going to make it a parabola. So that means what's going to happen is it's actually going to go up on both sides because what we've done is we've multiplied it by a positive 2. So it's going to look something like this. So left end behavior, x approaches negative infinity. Right end behavior, x approaches positive infinity. We'll just put f of x again here as a shortcut. And what happens on both ends is it goes up, heads up toward positive infinity. So these are both going to be positive infinity. Put a circle around that, and then we're all set. Okay, we'll take a look at the last couple here. So this is the average rate of change. So remember, this is delta y over delta x. This is y2 minus y1 over x2 minus x1. The way we're going to think of it is this. We're going to use function notation for this. So we're going to do x2 minus x1, f of x2 minus f of x1. So this is going to look like this. This is the first x, this is the second x. So on the bottom, we've got a 4 minus 0. On the top, I have an f of 4 minus an f of 0. So let's see what we get here. If we plug in a 4, we get 4 squared, so that's going to be 16, minus 8, and then plus 4. So that's going to be a 12. So this is going to be a 12 right here. Minus, if you plug in a 0, that's a 0, that's a 0. This is going to be a 4. And on the bottom, we still have a 4. So this is 8 over 4. We end up with 2. So that's the average rate of change. Again, we're thinking about what goes on there, what that actually means about the graph. And then on this one, I'm going to do this one a little more quickly. So this is x1, this is x2. So we're going to do 3 minus the minus 2. Then I'm going to do f of 3 minus f of negative 2. So this turns out to be a 5 because this is going to be a plus. And then I've got f of 3. So that's going to be, plug in a 3, that's going to be a negative 9. That's going to be plus 18 minus 10. So that's going to be a negative 1. Okay, when I plug in the negative 2, that's going to be, let's see here, it's still going to be negative because we've got this square, negative 2 squared would be 4 with a negative in front of it. So that's negative 4. This is a negative 12, and that's a negative 10. So altogether, that's a negative 26. Now, let me show you a common mistake right here. What people do is they look at this and go, oh, that's a subtract, that's what I'm expecting and stuff like that. But we forgot to put the minus that's part of the formula. Remember, this is x2 minus x1, f of x2 minus f of x1. So we've got to make sure that minus is represented there. So we're going to put a negative right there. And then we've got that minus 26. That's going to be a plus 26. So we have 25 over 5. Answer on this one, 5. So again, think about what that means on the function. Think about what that means on the slopes because we are talking about rates here. Now on this one, we said an object was drop off a building, and this was its height. And we want to know the average rate of change from 0 to 2 seconds. So this is time 1, and this is time 2. So I'm going to do T2 minus T1, f of T2 minus f of T1. So we're going to do a 2 minus 0. And then on the top, if we've got 2 minus 0 on the bottom, this is going to be f of 2 minus f of 0. Again, drawing this out just a little bit. So that's a 2 on the bottom. And then on the top, I have f of 2. That's going to be 150. Minus f of 0. That's 200. And then I end up with a minus 50 over 2, which ends up being negative 25. Now, if all you did was this and you never thought about the units or anything, it's tough to interpret. But remember, the time is measured in seconds, and that goes on the bottom. So time in seconds on the bottom. The height is measured in feet, so that's feet. So this is negative 25 feet per second. Okay? Now, if we were going to write a sentence for this, we could say the object is falling at 25 feet per second on the interval from 0 to 2. Now, we could say something like the interval is falling at an average rate of 25 feet per second on 0 to 2 seconds or something like that. But this is good enough. That'll get you what you need. All right, good luck on the test.